Mangroves. An infomercial. Presented by Group 2. Grade 8. Enif. Filipino subject. What's a mangrove? If you've ever spent time by the sea in a tropical place, you've probably noticed distinctive trees that rise from a tangle of roots wriggling out of the mud. These are mangroves, shrub and tree species that live along shores, rivers, and estuaries in the tropics and subtropics. Mangroves are remarkably tough. Most live on muddy soil. But some also grow on sand, peat, and coral rock. They live in water up to 100 times saltier than most other plants can tolerate. They thrive despite twice daily flooding by ocean tides. Even if this water were fresh, the flooding alone would drown most trees. Growing where land and water meet, mangroves bear the brunt of ocean-borne storms and hurricanes. The word mangrove may have originated from the Malay word mangi for the mangrove plant of Vicia and combined with the Arab word elgurum, to become mangurum. How do mangroves survive under harsh conditions? A remarkable set of evolutionary adaptations makes it possible. Can cope with salt. Salt water can kill plants, so mangroves must extract fresh water from the seawater that surrounds them. Many mangrove species survive by filtering out as much as 90% of the salt found in seawater as it enters their roots. Some species excrete salt through glands in their leaves. These leaves, which are covered with dried salt crystals, taste salty if you lick them. A third strategy used by some mangrove species is to concentrate salt in older leaves or bark. When the leaves drop or the bark sheds, the stored salt goes with them. Mangroves hoard fresh water. Like desert plants, mangroves store fresh water in thick succulent leaves. A waxy coating on the leaves of some mangrove species seals in water and minimizes evaporation. Small hairs on the leaves of other species deflect wind and sunlight, which reduces water loss through the tiny openings where gases enter and exit during photosynthesis. On some mangroves species, these tiny openings are below the leaf's surface, away from the drying wind and sun. Breathe in a variety of ways. Some mangroves grow pencil-like roots that stick up out of the dense, wet ground like snorkels. These breathing tubes, called pneumatifers, allow mangroves to cope with daily flooding by the tides. Pneumatifers take in oxygen from the air unless they're clogged or submerged for too long. Roots that multitask. Root systems that arch high over the water are a distinctive feature of many mangrove species. These aerial roots take several forms. Some are stilt roots that branch and loop off the trunk and lower branches. Others are wide, wavy plank roots that extend away from the trunk. Aerial roots broaden the base of the tree and, like flying buttresses on medieval cathedrals, stabilize the shallow root system in the soft, loose soil. In addition to providing structural support, aerial roots play an important part in providing oxygen for respiration. Oxygen enters a mangrove through lenticels, thousands of cell-sized breathing pores in the bark and roots. Lenticels close tightly during high tide, thus preventing mangroves from drowning. Ready-to-roll seeds. The mangrove's niche between land and sea has led to unique methods of reproduction. Seed pods germinate while on the tree, so they are ready to take root when they drop. If a seed falls in the water during high tide, it can float and take root once it finds solid ground. If a sprout falls during low tide, it can quickly establish itself in the soft soil of tidal mud flats before the next tide comes in. A vigorous seed may grow up to 2 feet, about 0.6 meters, in its first year. Roots arch from the seedling to anchor it in the mud. Some tree species form long, spear-shaped stems and roots while still attached to the parent plant. After being nourished by the parent tree for 1 to 3 years, these sprouts may break off. Some take root nearby while others fall into the water and are carried away to distant shores. A world traveler. Botanists believe that mangroves originated in Southeast Asia, but ocean currents have since dispersed them to India, Africa, Australia, and the Americas. The fruits, seeds, and seedlings of all mangrove plants can float, and they have been known to bob along for more than a year before taking root. In buoyant seawater, a seedling lies flat and floats fast. But when it approaches fresher, brackish water, ideal conditions for mangroves, the seedling turns vertical so its roots point downward. After lodging in the mud, the seedling quickly sends additional roots into the soil. Within 10 years, as those roots spread and sprout, a single seedling can give rise to an entire thicket. It's not just trees but the land itself that increases. Mud collects around the tangled mangrove roots, and shallow mudflats build up. From the journey of a single seed a rich ecosystem may be born. Why mangroves matter? Mangrove forests were once generally dismissed as swampy wastelands. Planners, scientists, and coastal dwellers have now come to value them as the remarkably diverse and important ecosystems they are. Keystone of a coastal ecosystem. Mangroves, seagrass beds, and coral reefs are often found together and work in concert. The trees trap sediment and pollutants that would otherwise flow out to sea. Seagrass beds provide a further barrier to silt and mud that could smother the reefs. In return, the reefs protect the seagrass beds and mangroves from strong ocean waves. Without mangroves, this incredibly productive ecosystem would collapse. Nursery grounds. Mangroves provide ideal breeding grounds for much of the world's fish, shrimp, crabs, and other shellfish. Many fish species, such as barracuda, tarpon, and snook, find shelter among the mangrove roots as juveniles, head out to forage in the seagrass beds as they grow, and move into the open ocean as adults. Clean water. Mangroves protect both the saltwater and the freshwater ecosystems they straddle. The mangroves' complex root systems filter nitrates and phosphates that rivers and streams carry to the sea. They also keep seawater from encroaching on inland waterways. Mangroves provide stable coastlines. Shelter for marine life from the storm. Rich resources for food, fuel, medicines, and many other valuable uses. Mangrove conservation. The continued exploitation of mangroves worldwide has led to habitat loss, changes in species composition, loss of biodiversity and shifts in dominance and survival ability. Environmental awareness, proper management plan and greater thrust on ecological research on mangrove ecosystems may help save and restore these unique ecosystems. In order to conserve these fragile ecosystems, the following strategies may be implemented. The local governments should formulate proper management policies for mangrove areas. Efforts should be made at village, district and state levels by the policymakers and NGOs. There is a need to involve people at the grassroots level, in the protection of these forests. Long-term research activities should be undertaken. School should chalk out the program with the students and their parents. The end. Sala. Mat. Po.